Assalamu alaikum. We know a quantity that can be measured is referred as a physical quantity. In the measurement of any physical quantity, we always come across some sort of error. What is this error? Error is nothing but uncertainty in the measurement. It can also be defined as the difference between measured value and the true value. In this video, we will discuss the different ways of analyzing error. Let's do it. I'll start with the absolute error. Absolute error. Absolute error is the magnitude of the difference between true value and measured value. The magnitude of the difference between the true value and the measured value. Okay, so now I will write this in the form of an equation. Here, absolute error. Now, can be referred as the magnitude of the difference between true value. Here, true value is subtracted from measured value. Measured value. Okay. Here, whatever the value that we get now, its magnitude alone is taken. Okay. Now, suppose I have a physical quantity A. Now, in physics, when we perform an experiment to measure a given quantity, we repeat the experiment several times. This repetition of experiment is to avoid or to reduce the error. So, to measure the value of A, the experiment is repeated many times. Suppose, for the first time, when the experiment is performed to get the value of A, here the measured value obtained is taken as A1. The second time, when it is performed, the value is taken as A2. Third time, A3, like that. Nth time, if the experiment is repeated n times, then the value is taken as an. In this case, the average, the arithmetic mean of these measured value provide me the true value. Okay, true value of the quantity. So, what is this arithmetic mean? Here I have used the term arithmetic mean. Sometimes it is also referred as average. Arithmetic mean or average can be obtained by adding all the given values and dividing it by the total number of the values. Okay, arithmetic mean can be obtained by adding all the values. Here I have got the n number of values. A1 is added with A2, is added with A3, now is added with A4, and then we go up to AN. And here total number of values is nothing but n. Now whatever the sum we obtain is divided by n. Then by doing so we obtain mean, arithmetic mean, and it is represented by letter AM. Okay, here M stands for mean. So here AM actually provides us true value. Okay, what does it give? It gives us true value of the quantity A. I hope you have understood. So This can be represented mathematically as AM, equals to sum of. For summation we use sigma. Sigma represents the summation. Now summation of all these values is taken as A. Now AI. Here I is equal to 1 to n. Clear? We have the value of I starting from 1 and ends at n. This is what it means. So, and here this, the sum of these values is divided by n. So, I have to mention one more thing here. That's nothing but 1 upon n. Clear? So, this is the arithmetic mean of all these measured values, which provides me the true value. Got it? Now, from this, how to get absolute error of these measurement? Now, I have n number of measurement for the value A, for the physical quantity A. Okay. So, in the measurement of A1, the absolute error is taken as delta A1. Here, delta actually represents the difference or change. Here, I told you at the beginning, absolute error is nothing but the magnitude of the difference between true value and a measured value. So, here, delta represents the difference or change. Okay. So, it's equal to the true value is AM. From this we subtract the measured value, that is A1. Okay. Now, if I take its magnitude is shown by modulus, then it will give me the absolute error in the first measurement of the value A. Then absolute error involved in the measurement of A2. The second time when we perform the experiment to find the value of A, I get the absolute error to be equal to modulus of delta A2 equals to modulus of AM minus A2. Like that, absolute error occurred in the measurement of physical quantity A nth time is nothing but modulus of delta AN is equal to modulus of AM minus AN. Understand? This is how one get the absolute error. I hope I have understood. Now, we'll move to another analysis of error. Another way of analyzing error. That is nothing but mean absolute error. What is that? Mean absolute error. As the title denote, here we take arithmetic mean of absolute errors involved in the measurement of a given quantity. Okay. So, mean absolute error is nothing but arithmetic mean of absolute errors in all measurements. Let me write here. Arithmetic mean of absolute errors in all measurements. Is referred as mean absolute error. And how do we represent this? In the form of an equation. Let me show this to you here. All this represents absolute error. If I take the arithmetic mean of all these absolute errors, then I will get mean absolute error in the measurement of a quantity A. Okay. So here I take all these absolute errors. I start with the A1, modulus of delta A1, start with modulus of delta A2. Now, like this we go. We add all the values up to an. Then the sum we have obtained is divided by total number of measurements we have done. Here total number of measurement is nothing but n. It gives me the average of absolute errors involved in these measurements. Okay, and it is represented as delta AM. Okay, it is represented as delta AM. Here M stands for mean. Okay, I hope I have understood. Now suppose I have a quality. Quality A. And the absolute error, the mean absolute error involved, or we can say the value of A will have error lying between, or its value can be in between A plus delta AM and A minus delta AM. So this clearly shows that the measured value of A will lie between these two values. Okay, I hope you have understood. Now we'll discuss another method of analyzing error involved in the measurement of physical quantities. Before I go ahead, let me give a simple example of absolute error. Suppose you measure your body mass and you know the correct mass of your body to be 60 kg. Is the true value, but on measurement you obtain the value to be equal to 59 kg. Then the absolute error in the measurement can be obtained by taking the difference of these two. The 60 minus 59 kg gives us the absolute error. That is nothing but 1 kg. This is the absolute error in the measurement of a given quantity. Here in this case, we have taken the mass of your body as a quantity. Understand? Now let's discuss another way of analyzing error. This is called as the relative error. Relative error. The relative error is nothing but the ratio between the ratio of mean absolute error to the mean value. Relative error is the ratio of a mean absolute error to the mean value. Here mean value actually represents the true value. Now I already have told you how to get the mean value of a given quantity which is under measurement. Yeah. Here mean absolute error is represented as delta AM and the mean value is represented as AM. The ratio of these two is referred as relative error, and it is otherwise referred as fractional error. This can also be referred as fractional error. Okay. Now another way of representing error is nothing but percentage error. Percentage error. Percentage error. Now suppose if you represent relative error in terms of percentage, then it is called as percentage error, like this. percentage error. Now is represented mathematically as delta AM upon EM multiplied with 100%. So here we simply represent a relative error in a percentage. Okay, and what does it tell? It gives us the size of the error involved in the measurement of some quantity. This is what it represents as. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put your questions in the comment section. Thanks for watching.